Hi everyone, welcome to the channel. My name is Jose Alberto, and in this video we are going to talk about the layers and blockchain. Alright, so let's go. Okay, let's start here. First, the thing important here is understand why it matters. So now the big question is, as I said, why is this important? If you are a developer building smart contracts, a folder launching a dApp, a trader trying to save on gas fees, or even a research designing cross-chain infrastructure. So understand layer 1 and layer 2, or L1 and L2, helps you to first choose the right deployment strategy. So this is very really important. Optimize the second, yes, reason to you need to know about this knowledge. Optimize for costs and performance. Free for design for scalability and for to understand security trade-offs. So it's just like understand front end and back end. uh, if you're a web developer, you can build efficiently without knowing where things run, so what's secure and where the bottlenecks are. So that's why know the layers is so important. Okay, so no more talked about that. I think that you understood. Now let's start. Why is layer 1? Okay, a layer 1 or L1 is the base layer of the blockchain protocol. Is where the entire chain's core logic happens, including transactions, validation, consensus mechanisms like proof of stake or proof of work, as we said in another video before. We're going to talk about two state transactions, on-chain execution, data availability, and final settlement. All the things that I finished to say now happens in layer 1. So all nodes on the network must reach consensus on every transaction and update the global state. Okay, so one let's talk about some examples about layer 1 blockchains include. We're talking about the Ethereum, Bitcoin, Solana, BNB chain, Avalanche. These all example they are happening in layer 1. So each one defines its own consensus model and virtual machine. For example, Ethereum uses the EVM, while Solana has a parallel runtime architecture. So, but all of this, even Ethereum, even Solana, they are in layer 1. Okay, this is about layer 1. Now, why layer 1 has limits? Okay, now here's the issue. Layer 1, we are until talking about layer 1. Blockchains are monolithic. Okay, so meaning, what is meaning? Mean everything, consensus, execution, data availability, everything that happens in layer 1 just happens in one place. We don't have other place. So imagine we are talking about a lot of people, yes, a lot of people, let's say that, using the same room. All right, this is not so efficiency. All right, so this design ensures security and decentralization, but sacrifice what? Scalability. So we don't have scalability in layer 1. All right, for instance, let's say that Ethereum handles about 15 transactions per second. Okay, during peak usage during peak usage gas fees can spike to $50 plus just to approve a single transactions. Yes, yes, yes. A single transaction, yeah, can spike that. Do you believe that? Okay, so this is known as the blockchain trilemma. You can have all three at once: security, decentralization, and scalability. We need to have these all things: security, decentralization, and scalability. We're going to talk about security, decentralization, and scalability. Scalability. In layer 1, we have security and decentralization. But how can we get the scalability? That's why we have layer 2. That's where layer 2 comes in. A layer 2 or L2 is a scaling solution built on top of the layer 1. Okay? It offloads parts of transactions precision off-chain while ensuring security and data finally back to the base chain. So, in other words, layer 2 handles the heavy lifting, execution, bathing, and proceeding. Okay? And that uses layer 1 for verification and final settlement. Alright, so here in layer 2 we have a scaling solution. Alright, scaling solution. So parts of the transaction proceed off chain. Alright, and the concessions in layer 2 we have inherited from layer 1. About security, in layer 1 provided by its own validators. So in layer 2 anchored to layer 1. So are you seeing that layer 2 depends of the layer 1 in anything we are talking about security and decentralization. Okay, so throughput, layer 1 is low. We're going to talk just a 15 PTS on Ethereum for instance, but in layer 2 it's very high. We're going to talk more than 1000 TPS. Yes, it's really fast. About fees, in layer 1 is high, in layer 2 is low. And examples about layer 1 we have Ethereum, we have Solana, Bitcoin, and layer 2 we have ZK Sync, Arbitrum, Optimism. Okay, so this is really, I think that just here I will show you this table. I think that it will understand better. Alright, so you're going to see this table right now. Okay, so just to finish, as I say, layer 1 is security, decentralized, but is low. And layer 2 is scales the system, it does so without compromising the security guarantees of the base layer. And just to conclude, okay, layer 1 is the base blockchain. It handles full execution and concession, but is limited in throughput. And layer 2 sits on top of layer 1, offloads computation, and puts back proof of data, giving us scalability and low fees. And as I say, layer 2 depends of the layer 1 for security and decentralized, but layer 1 depends of the layer 2 for have scalability. And know how to use both in key is build the next generation of Web3 application. Okay, so in the next video we are going to talk about another themes. And thank you for watching. If this video helped you, please give like, share, and do the comments. Okay, bye bye until the next video.